Okay, so let's say you wanted to like send multiple assets to somebody. So basically multiple coins. So you want to send somebody USDT and USDT SUI at the same time. Or let's say you wanted to evacuate a wallet. You want to switch wallets and you want to send all your coins, right? How do you do that? It's a whole lot similar to what we did with the batch transfer contracts, right? So the airdrop package, but in this case, we're just sending different coins, right? So that's it. I'm just going to head onto my terminal. As you can see here, I already created the package and I named the evacuator, right? And also opened it in my VS Code. So you can see here, I already opened it here and it's named send coins, right? So they created the send coins module, right? So the first thing, just getting straight to the point, defining the function that sends everything. So let's just do a public entry function, and then let's call this evacuate wallet, right? So evacuate wallet, and then of course we want this to also accept any tokens at all, because in this case we're trying to like send as much tokens as we can. So just t and then store, and then we can now enter the vectors, right? So it's more like enter the recipient address first, because this time around we send it to one wallet, right? Not multiple wallets, one wallet. So the recipient is an address, a single address, and then the amounts. We should actually do an amount vector, and the reason why I'm doing an amount vector this time around is because let's say it's not everything you want to send. Let's just assume that you wanted to send half of the balances to different wallets, like for your security and all of that stuff. So let's still use the vector, right? Let's not evacuate the wallet entirely. And so this is going to be a vector of 64-bit integers. And then the next thing you want to specify is actually the coins, right? So you want to specify all the coins in the command. So it's like a vector of coins, right? So let's call it coins, and this is supposed to be mutable actually. So this will be a vector of the coin, and then finally we specify the transaction context. So it's a mutable reference to the transaction context as usual. So ctx reference mute tx context, and then let's import the coin as well. Use coin, use SUI coin, and then important self, because I thought we'll still eventually use the coins functions and all of that. So that's it. Now let's write the body of our function. Okay, so first thing is we want to do a length mismatch, because we need the amount of coins to be equal to the amounts. So let's just call it allocations instead, right? So we need the amount of coins, or the number of coins we're sending to be equal to the allocation, so that we know that okay, the amount of coins that we are sending out is the same as the allocation, and then we can now send for each index. So in this case, let's do const mismatch. Let's call this mismatch, and it should be a 64-bit integer that's equal to 404 again. And then just open this up, and then we can now always do our sessions, right? I feel like I started something that going to be using a lot, so it's very important that I just bring this back. Okay, so let's the number, so pretty much the allocations length, so let's call it allocation len, and it should be equal to the length of the vector. And so in this case we want to do both the allocations vector, right, and it's a reference, right? So there's that, and then we also want to do the same thing for the coins, right? So we want to be sure that they have the same length. So just changing this to coins, and then changing this to coins, pretty much. Okay, now that said, the next thing we want to do is assert, right? So once I said that both of them are equal, so assert that this, assert that this is equal to this, and then through this if they are not equal, right? That's it. Next thing we want to do is, of course, write the loop that actually loops through and then sends the coin, right? In this case, we're going to learn something that's quite useful. So, so now let's specify the index. So it's like let's mute I because it's going to eventually change because it's 0. And then now we write our loop, right? So while I is less than any of the lengths, so we just use coins at length, right? While I is less than that, then what we want to do is specify our condition. So in this case, first thing we want to do is, of course, and then in this function, what we want to do is first specify that we want to get the last coin, the ownership of the last coin. So the first thing we want to do in this function is actually to get the ownership of the last coin, right? And then we eventually borrow the amounts, split the coin, and then transfer. So how we're going to do this is as easily as getting the coin. So let mu coin and then be equal to, then access the last element. So it's vector pop back and then specify the vector. So in this case, it is the coins vector, right? I'm having an error, couldn't infer type. This actually should be mute, right? So yeah, that should work. And then the next thing I want to specify is the amount. So similar to what we did before, let this be equal to then borrow, right? So vector the borrow, and then specify the vector here. The vector is allocations, right? So allocation. Right. And now the next thing I want to do is now split, right? So in a case where you are sending a particular amount, or even if you're entering the balance, splitting is always a good idea, especially if you want to run this from a terminal without using like a client, right? And so I'm just going to do let portion be equal to sui coins. Let me actually just import it. Already did it actually. So it's coins coin dot split. And then first thing we want to specify is actually the coin, then the amount and the transaction context. So in this case, it's a reference to the coin, immutable reference actually. So, and then the amount, in this case is amount, the amount variable, and then transaction context. Now, the last thing we want to do here is actually to do the transfers. So it's transfer, public transfer, and then we want to send portions to the recipient. So portion to the recipient. Now, there's still a problem here, and the problem is because we need to properly clean and destroy all coin objects when we're done. Like, let's say we are exhausting all balances, right? We need to. Okay, so the last thing we have to do here is actually sending the coin. So we have to spend the remaining balance, right? We have to send it to somebody. So in this case, you can send it back to anybody. You can send it to your address. You could send it to the recipient again. So you also have to like just easily paste this and then just send it somewhere. And then in this case, it actually makes a lot of sense because this is like things that keep you safe, right? So finally, you want to increment the index. So it's I is equal to I plus 1, and then we can now destroy the vector, the coin vector. And so the way we do that is this: we just use vector destroy empty. So it's vector destroy empty. So destroy underscore empty, and then specify the coins. So in this case, it is coin. So we want to specify the coins, right? So easily coins, or whatever we call it here. Yeah, we call it coins, right? And so that's everything. Everything should work fine. Let's build this. So swim with build. Yeah, and everything builds. You can see the artifacts here, and that's how you do it. So when you publish this and you execute a contract call, the amount of coins you specify with the vector according to the recipient, sorry, according to the allocation, should get sent to one address.